Okay. So today we learn about half adder, and then we learn about full adder, and some if we have more time lah. It's basically we only have about 1 hour lah left. Okay. So we learn about first is a half adder. Half adder means the word itself means it is not complete. Okay, it is not complete to perform adder. Okay. So but we learn this half adder first in order for us to familiarize for the next one, which is the full adder. Okay, the difference between half adder and full adder is that full adder have a carry in. Okay, full adder has a carry in, half adder didn't have. Okay. Okay, so this is half adder. Where's the, you see it's difficult this one, how to okay. Okay, so this is half adder. How you going to write this half adder? H A. Okay, so H A. So half adder. So you can see this is AI, this is your input, this is your output, S and I. So this is sum, this one is carry in plus 1. Okay, so this one is AI, this one is BI. Let's say I is equals to 2, for example. Okay, I directly use different numbers so that you can see the correlation, the relation. Okay, so your A will be, for example, your A will be 2, your B will be 2. Okay, this is to so that you can see the difference, and then half adder, and then this is SI, means I is 2, and then the next is carry in plus 1, I1 plus 1, so 2 plus 1, so it is a C3. Okay, means this one A2 plus S2, and you get the result S2, and if you have extra, it will be carried into the next half adder. Okay, to the next half adder. Okay, so now, okay, I hope you watch. Okay, I cannot force you like, please, Iyad, please Musab, please Shakira, please Osama, please watch my video. I cannot like that. This is not school. Okay, please watch my video. And I told you when you come for my lecture, is I top up what the lecture didn't provide 2021 first. Second, I will do like summarization, because you, if I do complete lecture, it will be long. You will like have like, for example, part 1 2021 1 hour, and part 2 1 hour also, then it's like 2 hours. Okay, so that's why I do like summarization. Okay, so A, you see here is AI plus BI. Okay, 0 plus 0 is equals to 0, so no carry. Okay, the same goes also for here, 0 plus 1, so you will end up with some 1, however with no carry. And then the same also, 1 plus 0, you will have the summation of 1 but no carry. If you have 1 plus 1, it is already like overflow. So I means like you have to carry 1 to the next one. Okay, 1 plus 1 2. Okay, so and then the next, of course, they want us to do the circuits, to do the equivalent circuit. So you see the relation here. Okay, what is the one that having the output of 1? Only this one and only this one. Okay, let's say for the CI plus 1. Okay, so only this one having the uh, output of 1. So CI plus 1 is actually A, B bar, A, B. And because it can be 1, 2, 3, 4, 5, whatever, so that's why we just use, okay, we just use I. Okay, Okay, so this settle for the carry. So now let we see about for the summation. For the summation, you don't look at this, you listen to my word. You're not going to learn if you don't. Okay, now you see this one, we have 1 plus 1, and we only have this one if and only if this one is different. The input different. Regardless of combination, it is different. For example, if this one is 1, the next one is 0. If this one is 0, the next one is 1. So this one is actually XOR. So in order to get SI is actually an XOR. Okay, and it can be any of the stage, whether I1, I2, I3, and so on. In order for us to, sometimes we want to have more outcome from an operation, we cannot have only one. So normally we will do cascading. Okay, cascading is that this one will be fit to this one, and this one will be fit to this one. Okay, and you can have C in here, CI, for example, CI1. Okay, and this one is C2, and this is will be C3, but it will still carry. Okay, it still carry. And then we have, for example, the input here. Okay, and then we have the input here, and input here. Okay, and this is carry in, and you have the other, this one, the sum, or the, we can use put as the word output. Okay, so the full adder is actually what the full adder have that the half adder didn't have. Like I told, is it has the C in. Okay, means it have the past input or previous input from the previous stage, from the former stage. Okay, so this is the difference. Okay, now I have to wait this to go up. Difficult lah, but inshallah next year will be, not next semester will be like face to face lah, easier. Okay, so what full adder have that half adder didn't have is this lah. Okay, so this is just normal operation. Okay, your binary 0 plus 0 plus 0 equals to 0 and no carry. The same here until here. Okay, then you start to have 1 plus 1. 1 plus 0, 1. 1 plus 1, 1. Okay, that's why you have sum 0 and you carry to the next is 1. Okay, next you have 1 plus 1, the same as well, regardless of combination. 1 plus 1, 1 0 plus 0, so that's why you have this. Okay, sum of 0, but carry to the next is 1. Then you have 1 plus 1 plus 1. Okay, 1 plus 1 plus 1, so you have sum 1 and you carry 1. Okay, this is actually 1 plus 1, okay, plus 1. So what is the answer lah? Okay, so then you see the, you can see now the, if you want to make a logic circuit, if you want, okay, for example, if you want to obtain Ci plus 1, okay, what is the one that will have okay, I have to wait again this Webex to go up, otherwise I cannot press the button. I think you guys can see also, right? This one. Okay, you see how inconvenient it is. Okay, so now we want to see the one that produce 1. Okay, because we want to make a logic circuit, we want to make an expression. Okay, so you see this one is 1 1 1. So what is the case that going to make this as 1? Okay, you try this at home. Okay, try this at home. The answer is already there because I give you full half adder. From the understanding of half adder, you try to relate how you actually, for ABC, how to relate ABC in order to get your SI and you get your CI plus 1. Remember, you need to compare with the one that having output of 1. If it want you to have, like for example, maybe it will mention output high, or if it's mentioned what is the boolean expression or algebra or whatever for SI having output 0, then it's not. This one means what they want is actually how to get the 0. So depends on what question you get. Okay. Okay. So this is the answer. Okay. CI, ABI plus ACI. So because you have 3 output, right? Having output 1. Okay. So this answer is here. Okay, the answer is here. What you do is you need to do first before you see this. Then you will understanding better. Okay. Don't look this. Okay, I will try. Then you will not learn because you already know the answer. Okay. Now, this one is the what we call is in order to have a full adder, like I told you, sometimes you want to have more complete operation or more bigger operation. We can do cascade. For example, this is a full adder plus 1, okay, version 1, and you have full adder version 2. Full adder version 2 is made up by a 2 half adder, okay, in order to get one full adder. So you have full adder. This one is the classical in the sense that we derive from the equation here. Okay, we do directly, and full adder, we get the same result. Why you need, but you need to do some modification. So my question, only those that actually watch my video can answer, and even if you can, if you remember. Okay, so what I want to ask you now, which one is faster, full adder version 1 or full adder version 2? Can you answer me? Which one is faster, full adder version 1 or full adder version 2? V1 or V2? Okay, so V2 is more faster actually. Okay, um, I explain detail lah. I explain a bit detail in the 2021 lecture, and it is explained in the module. However, just simple lah, just simple understand logic. Just simple logic. You see, you will refer to my previous lecture. I explain detail and also in module. But this one is just simple lah, logic. You see, this one is 1, 2, 3, 4, 5, 6. So there is 6 logic gate. This one is 5. So this is faster lah. Easy to make you understand. Okay. But you want detailed information, please refer to my video. Okay. You can see, right, the more, if we have more logic gates, it will create delay. That's why sometimes the delay, we want the delay, but we don't want to change the output. So we use buffer. Okay. So now it's a 4-bit ripple adder. Okay. Okay. So what does it mean by ripple adder is ripple, because it will go, if we see the movement from the input towards the output, we will have like a ripple because we have the input going, sorry, okay, we're going to have input like here, okay, then it will be continue to here, so like a ripple, okay, because it move from here to here to here and to here, so it's like a ripple lah, okay. So I explain also in detail in the 2021 lecture. Okay. So this is a ripple adder. So normally the first of the full adder we put 0. Okay, normally. Okay, but don't assume if it doesn't state. Okay, if it doesn't state, of course you will use 0. But if it state, you need to make sure what this question. Maybe the question can try to manipulate to make you life a bit difficult. Maybe the question, for example, the final will say, for example, final say the input is 1. But because you only assume, okay, it's always 0, then okay, I will do like as if it's 0. Then finish the whole question because everything that you solve until the end is also depends on this. Okay? If it doesn't mention what is the input, what is the earliest input, if it doesn't mention, it is 0. But if it's mentioned, you need to read the question. Okay. So, so this is the SO is the output, okay? And this is the carry, okay? I think I make some mistake just now. Okay, sorry, Okay, for example, if we have a carry, okay, carry in, and you have carry 2, then you have the sum here, right? For example, the sum here. Sum can be up, I didn't do based on order. So this one can be put here. This is A0, S1, and this one can be S2. And this CI will be connect to the next one. So what I made mistake just now is I put C here. Okay, it's not C, okay, it's supposed to be carried to the next one. Okay, the one that we will take is the one that is the S, the resultant operation. Okay, so A0, B0. Okay, so what is do is that A0, B0 is that 1 plus 0. You get what? 1 plus 0? 1 plus 0, you get 1 and carry 0. So it will be 1, and the one that going to next is the 0. Okay, and then 0 plus 1, 0 plus 1 is 1 with the carry of 0. So you same, this one is 1 and this one is 0, and so on. Okay, so this is a ripple adder. Okay. Which one? Sorry, I want to know which one more difficult? Question 1 or question 2? Test 1. Which one is more difficult? Question 2 or question 1? Oh, okay. Okay, now you can see question 2, not because of the question, means that maybe you know where is your weakness. So I think the same also, you learn additional mathematics for the Malaysian that study Malaysian education. You learn from the means you need to work hard more. Okay, you need to work hard. No shortcut. You need to do many exercise. Okay, you need to do many exercise. No shortcut. This is digital electronics. You will learn more challenging subject later on. Okay, the electrical subject. Okay, I'm teaching electrical subject. The next maybe they will send me to teach signal, electromagnetic field theory, or principal communication. Okay. Not sure, okay, but depends on the assignment, okay. But for example, you need to always make perfect. Practice makes perfect. Go to online, learn. For example, question, just like trigonometry, for example, sine, theta. This one, a proof it is equivalent to 1 cos cotangent theta over 2. For example, in digital electronics also we have try to prove A bar B plus C plus E, for example, is equals to A. How you solve this if you don't remember the formula, the expression, and if you don't practice, because in exam the practice will make you. Will help you, because when you do a lot of practice, you will become more expert in solving the question. You already know, oh, for example, this kind of question, I can do absorption first, or I can do association first. But if you don't do practice, and suddenly you just do what I ask you because of the module, because this one, and because the answer is already in the module, so it will not help you. Okay. Try to search for more online exercise. For example, A like this, A bar plus AB. So what is the answer? Can you guess to me? What is the answer? A bar plus AB.
A plus B.
Nur Akilah, apa jawapannya? Nur Akilah, are you here? What is the answer here, Nur Akilah? Answer me. I mean in the WebEx chat. No, Akila, what is the answer here? Bukan, dia tambah lah kan? So it's what? Ni lah kan? No, Akila. Yes, rug. You see? Even simple question, only one student get right. And this is actually the simple one. The question will not be so generous. Give this very direct. This one is actually from the rule. Okay. I can give also, for example, A plus A B. So what is the answer? It is A plus B. Okay. So practice. Practice. Okay. So now we just now is a bit advertisement. Okay. So now we have the binary subtractor. Okay. So I am waiting, you guys. I am waiting for the class, extra class, for the quiz and also for the test. I don't know whether Ayu have asked you or not. Ayu have asked you guys or not? Where is Ayu actually? Is he in the class? Ayu. Have Ayu asked you about the class? Did she ask you about the class? I mean, she asked you to you guys opinion for the class, extra class? Because I'm plan to have extra class. Extra class. One is for quiz 1 until 3. One is for test 1. Okay. But I cannot proceed if you guys don't inform me of the, don't suggest me on the class. Okay. So I don't know, where is you? Did she ask you guys or not? I don't know. Did she ask? No. Oh, okay. This class is for you. So hopefully you will inform me when. Okay. When you guys can. And maybe I will not record because it's not compulsory to attend class. I will not record. So it is purely the benefit of those who attend. But if you don't attend, no because it's not compulsory. Okay. But I'm waiting. I'm waiting. Okay. So next is the binary subtractor. Binary subtractor is actually okay, binary subtractor is the word binary subtractor. Okay. Sometimes I mix up with the test one question because I worry of the test one. No, I worry because I already see how you guys doing in your okay. So when the question, for example, the question asks you about in 8 binary system. So all of the questions should be solved in 8 binary. You shouldn't put 9 divided by 3 like this. No. It should be uh, it should be solved in manner that it is in 8-bit binary. For example, 9 and 1's complement. What is the 8 binary? So you should put 8 binary equivalent. Okay. And then you have, for example, negative 9. Okay. What is the equivalent? So normally we have 1 here to show it is a negative number. And then we have here. Some of you do question good. You can solve. But the problem what? You suddenly, your answer is only in 6-bit. Where is the 8-bit? The question asks you to solve in 8-bit binary. Okay. Okay, now n-bit adder f equals to a plus b can be converted to a subtractor g a plus b. Okay, this one is if we do manual. We can, for example, 10 plus 10 minus 3, 10 plus 3 plus 3, for example, 3 plus 3, 3 minus 3, 3 minus 6. But in here, we need to make it into complement first. Okay, so you can make it like this. For example, this one is to make you understand first. So G equals to A plus negative B. Then you have, so what should we do about this one? Can you guys tell me? Don't read this, don't read this. It's no use if you read this and you answer the question here. I want you to think. Don't read this one. Don't need. Oh, too late, but please. Okay, so this one is A, nothing wrong. But how about negative B? What should we do? What should we do with this one? Can you guys answer me your question? Can you tell me what should you do this? No, you yes. But what else? Other than two complement, what can? Only two complement What else? Other than two complement, what else you can do? This I want you to to help you to think because in exam no one will help you to think it's you helping yourself. Now I'm here actually helping you to think, but I cannot help you if you don't answer my question. I don't want you to go to my class like watching movie. That's the problem. I didn't know you know or not. But I am trying to help you to answer, but I cannot help you if you don't want to help yourself. The rest, okay, it's okay. Just put your answer. No, nothing. If you make mistake, it's okay. But this is the only time that you make mistake because in exam you make mistake, no mark. Are you handling wedding pakcik? I there is also student ask me about personal things. If I if okay, maybe this is recorded session Okay. I have no comment. If I cakap tak boleh, student complain. If saya cakap boleh, if I tell you okay, it's okay, then student okay lah. So it's depend on you lah. Okay. I treat all of you as adults. Okay, as adults. So if you depends on you for the class. Okay, depends on you on the class. If you think it's important to attend, it's up to you. If not, I also cannot force it. Okay. I treat all of you as adults. Okay. Okay. Because actually attending the live session and watching the recorded, I don't think it's the same. The feeling is not the same because if you have something wondering during the live, it's only happen during the live. It will not maybe happen during the recorded. And the recorded maybe you don't really focus. Okay. This depends. It's okay. It's okay. I don't want to lecture you because I don't want to lecture all of you. I want to cover the syllabus and hopefully we finish. But if you have any other things to do, it's depend on you. Okay, it's depend on you. Okay, I will not do like it's okay. Never mind. I don't want to waste my time here. Okay, so here, so you see this one is negative B. So the question, if the question didn't specify, what should you use? Okay, you can use anything that actually can represent this one in negative number. So it is not only two's complement. You can use one complement and you can use sign magnitude. Understand? Okay, that's why we don't have direct minus, but we can perform addition with minus number because it is the same. So that's why from instead of a minus b, okay, in digital algebra we can use a plus minus b. But this one need to be converted first to the complement number. Okay. So okay, it's already shown here lah. Okay. And this is being tested in your test one question. One asking for one complement, two is asking two complement. Okay, who make question number 1? I make it. Okay. This one is 4-bit subtractor, okay? So if we this is binary, you already know. Now how we want to see if we want to see in terms of the logics, okay? So what you can see okay. So what you can see is here, okay? So this is your subtractor. This is your binary negative number, but depends again I told you depends what is this are you going to use one complement, are you going to use two complement, or are you going to use sign magnitude? Make sure you versatile in all of this because question can give you anything. Okay, for example in test 1 it tests you the knowledge of one complement and also two complement, but it doesn't test you on the sign magnitude. So make sure you know all lah. Okay. But at least I asked two. I asked two question. I asked two. Okay. So and here you can see it is not start from 0. It start from 1. Okay. Okay. And bit adder fa plus b can be converted to a subtractor g equals to a minus b. First you need to complement lah. Okay. Invert b and 8 plus 1. You see here? Invert b and 8 plus 1. Okay, so that's why you have a 1 here. Okay, here. And then perform g equals to a plus negative b. So how we do the 2's complement? If you forget, because I will not repeat, you try to you try to read first and you see whether you get the same or not. Okay, because it's different, right? One complement is like this, how you obtain two's complement is like this, and sum into is like this. Anyway, I've been searching for you from the class start, just until you say you cannot, you come late. I was asking the class when is the extra class. So I am waiting. For me it's for me honestly you guys my student, no honestly for me it's okay if no extra class, because for me it's okay. I'm more relaxed, right? No extra class, but this extra class purely for you. Okay, but I cannot uh, do the extra class if the student didn't suggest me. Okay, it's okay Ayu, if not this week, if not this week, next week. But ask the friend, if not this week, next week, because this week I'm quite packed. I know. It can be next week. Okay, it can be next week. But please make it hurry so that I don't want, so that you are more ready for the next one. Test 2 is coming. Yeah, test 2 is coming. I don't know when is test 2. Quiz also is coming. When is our quiz 3? When is our quiz 3? 20, see? No, no, quiz 3, quiz 4. Okay. Quiz 4 is on the 28th. Okay. Okay. So do you, okay, now we go to the comparator. Okay. So comparator, let me take white pages first. Okay. So comparator is actually we compare, for example, you want to compare apple with banana. Okay. So this is comparator. Okay. So for example, you want to compare apple with banana, so they are not equal. Okay. If you want to compare banana white, yellow color and banana green color, they are equal in terms of they are the same fruit. Okay. And then you want to compare if this apple, okay, for example, this apple is bigger than this apple. So it's bigger or it's smaller or it's similar size. Okay, so this is what comparator do. It compare whether the bit or whether the symbol or whatever is equal to this the next the B. It can be any number or it can be any. For example, A can be 8 bit. This one can be 8 bit also. Okay, and A is equals to B, or A is greater than B, or A is less than B. Okay, for example, if this is 8 bit, means that you will have A0, A1 until A7. If it's also 8 bit, it can be B0, B1 until B7. Okay, but how we going to compare? We compare one by one. We compare from the most significant bit first. Okay, so whether it is equal or greater. So for example, this one I just do overview. I do this assuming you have watched my video, because I already told please watch my video. Please watch my video. Please watch my video. I put the link. Thing that you do is to click and to watch. But if this you didn't do, I cannot force you like please watch. No. Okay. So so A7 B7. For example, A7, I do some overview. For example, I just want to make the code, we don't waste our time. For example, 4 bit. 4 bit. So we have A3, A2, A1, A0. For example, it is 0, 1, 1, 0. And we have B now, B3, B2, B1, B0. For example, this one is 0, 0, 1, 1, for example. So what we can do is that we compare from the most significant bit. So 0 or A3 and B3, is it equal or greater or less? Can you guys tell me? Equal, greater or less? A3 and B3. So, okay. Open battery low. For continuation active pen. Oh, okay. Oh, I need to replace my battery. I need to buy more. Okay, so it is equal. So if it's equal, then we cannot determine whether A is bigger than B. Then we go to the next one. We go to the next one, the next significant bit. So now A2 and B2. A2 is smaller, greater or equal than B2? Okay. So from here, it is greater. So we stop operation. No more. No more comparing, because we already know that actually A is bigger. Why? Because at the most significant bit, second most significant bit, A2 is bigger than this one. So A in overall is greater than B. Okay? Okay. So digital comparator, we have two types of comparating. We have the equality comparator and we have magnitude comparator. Okay, the one that is more better, more flexible is this one, the magnitude comparator. Wait, I'm drinking some water. Okay, so equality comparator, they produce an output when two binary words are equal. They can be used for circuits such as security lock. Okay, I think I did I explain this in the video? Did I explain this in the video or I didn't? Yes, I explain. I explain. This is actually, for example, Joey, she want to put a password. I mean, she want to enter the house, but I mean her father house. Of course, the father said the password. And then the father said, this is the password, blah, 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 blah. Then Joey come to the house and she tried to put the password. Initially, her father already said this password, 1234. Then suddenly Joey come and Joey put 1235. Then it's not different. Then it is different. So this is one of the application of equality comparator. They are not equal. So what is the outcome? Joey cannot enter the house. Okay. So that's it. compare it is the same or not. Then we have the magnitude comparator. This one is more flexible lah because it can compare many outcomes, less, greater, or equals. Okay. Next, we have a 1-bit comparator. By the word itself, mean it's just 1 bit lah, 1 bit. So it's leg, less, equal, or greater. This one also explained in my 2021 video. Okay. So this one no need oh, wait this one I already briefed just now, so you can actually know 0 plus 0 0 and 0, is it equal, greater, what? They are equal. That's why sorry. Okay, so 0 1, is it 0 is it a, this one is greater or equal, it is less, so this one 1 here and so on. Okay, so now you can do this one. This is exercise. I would not force you, oh please Shakira, please do, please. No, I will not tell like that, but you try lah. Okay, you try lah this one. Okay, yourself at home. Okay, so next is a 4-bit comparator. This one I already shown just now. Okay, indirectly, but didn't show at the chip, but it's the same thing. So you see this one is the cascade. Depends. For example, it's going to compare A3 until A0 and B3 until B0. Okay, this one number is actually the number of the leg of the chip. Okay, the leg of the chip. Okay, so if we want to compare, they didn't put the number ke? Wait A less B, A B 1. Okay, so what you can, because it didn't show this truth table, what you can do before you go to this, you make a truth table of, you can make a truth table of 4 lah. 4. Okay, now my question. How many rows of truth table that you will have using this? How many rows? How many rows of row? How many row of A and how many row of B? In the truth table, how many row of A and how many row of B? Can you guys tell me? I want to see I want to see whether you understand or not. How many row in the truth table A will make and how many row in the truth table that B will make? No, Dayana and Akilah, you are half. You are correct, but not correct. So means that A will have 16 set and B will have 16 set, right? Because it's a 4-bit. So 2 to the power of 4. So you have 16. So 16 A and 16 B. Okay, try this. Try this. It will be not time consuming, but it's to test you understanding. Okay. So this is just like what I told just now, but it's comparing in terms of the chip, and you can see this is the cascading input. Okay, this one is the input. Oh, okay. I thought this is the output. Sorry. Just now I didn't read carefully. So this is the input. Now they put cascading input 0, 1, and 0. Okay, cascading input 2, 3, 4. 7, 4. Used to cascade multiple device 8-bit comparator using 7, 8, 4, 5. 7, 4, 7, 4, 8, 5 device. Okay, I hope there is image to show you. Is this one? Okay, so actually you can just Google, okay. So 7, 4, 8, 5. Okay, you can see it is this is the circuits. Okay, A less than B, A greater than B, A greater than B, A equal to B, and A less than B. So then you have another operation here. Okay, so this is for 4-bit magnitude comparator. Okay, 4-bit magnitude comparator, and it's mentioned 4-bit magnitude comparator wait, something wrong, because it didn't show A0, A1, A2, A3, 0. Oh, okay, it show here 0, 1, 2, 3. Where is B1, B2, B3? B1, B2, B3, where is B0? Oh, here. Okay, let's compare here. Okay, so make sure, because it said 4-bit magnitude. So you see, this is 4-bit magnitude comparator. Okay, is this one? You can see here. Okay, eh? Now I'm purposely looking this. No, I didn't know. Sometimes I'm do like silly thing here. I say okay. I'm do silly things here not because I didn't know. I know, but I show to you that actually many things can be found online if you want to learn. Okay, so I'm sure I'll just type here, then get this, then get this. Okay. I'm not sure this one is in module or not. Where is the module? I didn't read the module for this one. But is it in the module? Where is the module book? This one, 7485. 7485. Is it in the module? This one, 7485. 7485. I mean this one, the truth table. Because last time I saw in the old syllabus I saw in the old syllabus, I mean in the old module. I think I saw in the old module, but not sure here. Tak ada. Oh, tak ada. Oh, why they don't put? Oh, pelik juga. Okay. Wait. So I will put this like this. I put like this. Okay, I put in this. Later that's why I prefer to give you the slide after. Okay. If I give you slide before, then you get the outdated slide. Okay, I put here. Okay. And I put the information lah. Wait. You can find other. Don't need to wait for me. But it's okay. I just give you because I constantly I search already, right? So I put here. Okay. Okay. So make sure you watch this. No, you try to learn this and understand. Okay. Okay, never mind. Okay, make sure you understand. Okay. So this is comparing input now. Okay. So 4 times 4. Okay. So you have actually you have normally because it's comparator means you have 16, like I show you 16 bit, 16 of data and 16 of data of 4B. Okay. Now is what is this? Okay, then there is a don't care condition. Like I told you, okay. Now I told you how to understand one row. Okay, I don't know why in the module don't have. Okay, okay. But I worry it will ask in question, then you'll be trouble if you don't understand. Okay, so A greater than B. Okay, means if here A greater than B, then this one is don't care. Okay, why we don't care here? Can you guys tell me? Can you guys tell me why when A3 greater than B3, why we don't care of the rest? What do you think? I'm waiting for the answer. Why A3 greater than B3 and we don't care the rest? What do you guys think? No answer. Good. Because it is already known. It's big. Just like I told just now in the previously, I just told you, right? Because it is big. No no point to compare anymore. That's why it is a don't care. Because regardless, this is 1, 0, what? Regardless, we already know A is actually bigger. Okay? Then A3 greater than, less than B3. No need to compare anymore because no need to compare at the least significant bit because we already know it is already smaller. A is already smaller, and so on. Okay. So please, Abdallah, Hiba, Nadira, Nur Aina, Rak, Shakira, Najwa, Mayisha, Ahmed, Ayu, Mashhur, Nodayana, Musab, Muata, and so on. Please read this one by one and try to understand what. Try to understand each of these. Okay. So I already opened your eyes before just now, and I open again. Okay. So please understand one line by line. Why is it open? Why is it like that? Why they don't put one? Why is so they don't care? Okay. Now, next we go to the when I want to see. I sometimes worry also if I'm too fast because I didn't know you. When I know you understand or not when the quiz have been answered, but they one already like okay. I want to see the course information now. What was supposed to be course information now is 22 of May. Okay, I want to see what you should learn this week. Oh, multiplexer. Okay. If you notice, I actually know. I know actually from the very start my class is a bit fast. I know because I already have the pre-recorded. Second, I want to have more exercise with you, and then I believe that we have more and more exercise will be better lah. So I will share test 2 question. When is your test 2? When is your test 2? Wait, I need to open again. Test 2, test 2, test 2. When is the test 2? When is test 2? Test 2. Test 2, 16th of June. So please remind me, 16th of June, when? 16th of June. 16th of June. Please remind me, class leader, Ayu, or if you guys depend on Ayu, the whole class finish lah. If Ayu forget, please remind me on to share you the test 2 question here on the 9th, the past test 2. Is it okay? Remind me. Remind me on the Wednesday, on the 8th, because I need to search for the past question. If I don't find it, how can I give you? Okay. So remind me on the 8th June to give you 9 June past test 2 so that you can use your weekend, for example, 10, 11, whatever, to do the test 2. And we will go through maybe Sunday on 12th because I don't want this one. This one is too late because your exam is here. Your test is here. So I give you on the 8th. Then the 9 you will do. And then, I mean, the night I will give, then you will do sometime during the weekend. And the 12th, we go together. And here, you can learn what your mistake made, whatever, blah, blah, blah. Then hopefully better lah. So remind me, okay, on the 8th, okay. I ask Ayu lah, but if Ayu forget, the rest of you didn't get lah. Okay. So remind me on 8th June, okay, so for the past test 2. Okay. What else? This one I put already. This one is parity. Parity. Okay. So okay now I stop recording because we will continue parity next class. Okay. I don't want to overload you. Okay. We continue at parity after. Okay. Where is the stop recording? This one stop recording. Okay, I stop recording now.